This video goes over lesson 3 notes in your packet. If you want to copy down this table, just hit pause and copy it down. It's also available on the packet on the website. So moving on to this first set of examples, which utilizes the properties of exponents. So if you take a look at example A has two things that you're multiplying together with the same base. When we're multiplying things with the same base, we add our powers. So 1/4 plus 1/2 is 3/4. Now, when you add these, you have to have common denominators. So it's like 1/4 plus 2/4. You can also use your calculator if you need help with those fractions. On B, a couple different things that we're doing here. We have to distribute this 2 to both parts. So this isn't working, sorry about that. So when we have parentheses, we multiply our power. So 1/2 times 2 is 1, and 1/3 times 2 is 2/3. And then since we don't have the same base or the same power, and this would be a yucky number if we put it in there, this is as far as we can take it, so we would just leave it alone. Here we're going to distribute that negative 1/5 to both parts, which means we're going to multiply our powers, so that would give us 4 to the negative 1 and 3 to the negative 1. Can't have negatives, so we send them to the basement. So we have 1/4 times 3, which is 1/12. Here is a table that discusses properties of radicals. We didn't fill in that example box because we won't be using that in class. All right. Oh, sorry, mine. Okay, let's go ahead and go to that next example. All right, so there's a lot going on example on page 8. So here on A, we have two things being multiplied together. They have the same radical, which means we can actually go ahead and multiply them. So 12 times 18 is 216. My suggestion would be after you multiply, check to see if that is a perfect cube. And if it is, then go ahead and just find the answer. And if it isn't, then we'll do what we're going to do on example B. So the cube root of 216 is a nice number. It is 6. And you can type that in your calculator by doing 3 math 5 216. Question B. The perfect cube, or the cube root of 135 is a decimal, so we actually have to split this into a perfect cube and a not perfect cube. So you're looking at your perfect cubes list and you're dividing by everything, and 135 is divisible by 27. It's 27 times 5. Cube root of 27 is 3, and the cube root of 5 is stuck. C. When you are simplifying something with a radical inside of, or a rational exponent inside of a radical, one way to do it is to rewrite this in rational exponent form like this. And then what do we do with our powers here? We multiply. So this would be 4 to the 4/9. That's one way to do it. Another way to look at this is by dividing this power by the index. So 4/3 divided by 3, which is 4/9. Same thing on this one. We can either divide 4/5 by 2, which would be 2/5, or you can rewrite it in rational exponent form, which is still x to the 2/5. Okay, so on these, I always check to see if they're perfect cubes or perfect force, whatever the index may be. And if they are, then I just go ahead and reduce. And if they aren't, we have to make our two houses. And so here we take the cube root of 64, which is 4. And to take the cube root of this, remember you divide your power by your index. So that would be y squared. And so since both of those broke down, I don't have to build my two houses. That's my answer. However, on F, 4 is not a perfect fifth, and none of the other things are either. So we have to build our two houses, perfect house and the not perfect house. 4 is not divisible by any perfect fifth, so it goes in our not perfects. In order to go in the perfect house, variables to an exponent have to have an exponent that is a multiple of the index. So if there's 8 a's, we can put 5 of them in the perfect house, which leaves 3 in the not perfect house. If there's 14 b's, that means 10 of them can go in the perfect house, and 4 of them would be in the not perfect. And if there's 5 c's, all 5 of them get to go in the perfect house. So then we're going to reduce that perfect house. 5th root of a to the 5th would just be a, because 5 divided by 5 is 1. We don't write an exponent of 1. B to the 10 divided by 5, so 2. And c to the 5 divided by 5, so 1. and then our not perfect house gets stuck the way it is. And then we're done. We've reduced it. G is going to be really similar. So we build our two houses. Look at our perfect cubes list. 27 is a perfect cube that goes in 108. It's 27 times 4. There's 4 x's. We can put 3 of them in the perfect house, which leaves 1 in the not perfect. And we can put all 9 y's in the perfect house. So then we're reducing that perfect house. So the cube root of 27 is 3. X to the 3 divided by 3, so 1. And y to the 9 divided by 3, so 3. And then cube root of 4x gets stuck behind. So we're done there because we've reduced everything. H is going to be very, very similar. Go ahead and just do H, and you can check your answer. You can just pause it right now. Try it. You should get this as your final answer after you have tried it, paused it, and then checked your answer. All right, so this next section, adding, subtracting radicals. I'm not going to do all of these, but I will show you a little bit about it. You have to have the same radical in order to add them. So notice that these both have the fourth root of 5, and so we can add 3 plus 5, which is 8, and then the fourth root of 5 gets stuck behind. Now these do not have the same radical part, but anytime you're dealing with radicals, you always have to check to see if you can simplify. 3 is not divisible by any perfect cubes, but 81 is. It's divisible by 27. It's 27 times 3. And so we're going to rewrite that, break that down into its two factors. The cube root of 27 is 3, so we have 4 times 3, which is 12. Cube root of 3. And then we have negative 4 cube root of 3. So negative 4 plus 12 is 8 cube root of 3. All right, so check C, or go ahead and pause it, do C, and then you can check your answer and see if you got it right. This is what you should get. My work is shown if you look at the answer key of the packet. All right, and lastly, D does not have the same radical part. Neither radical can be simplified, so that is going to be our final answer.